Okay, so I'm going to go over the solutions to this assignment number 4. And again, your goal with this is to be able to do this totally without your calculator. So we're going to start with this first example where I have y equals sine negative 3x. Okay, first thing is, whenever you see the number in front of the sine or the cosine, that's the amplitude. And it's always absolute value, so your amplitude is 3. It can't be negative. Okay, the period, we have a formula, 2 pi over b. b is the number in front of x. So in this case, 2 pi over 1 is going to be 2 pi. And the period, excuse me, like the amplitude, is always going to be a positive number. Okay, there is no phase shift. Okay, so the idea, I want to just kind of reiterate a couple of things here. So the structure is a sine b x minus c plus d. That's your amplitude. This gives the period. That's a phase shift, and that's up, down like that. Okay? So the increment of the x-axis, what you always do on this is you always take the period and you divide that by 4. Okay, so our period is 2 pi. Divide by 4. You're going to have pi over 2. Okay, so the increment of the x-axis is pi over 2. Okay, so you want to be sure that you're solid on being able to take an equation and know the key components of that. Okay, so what we're going to do from here, we're going to fill in the table. So give me just a minute to set something up. So I need a unit circle. So presto, there's a unit circle. And I'll refer to this as we go through this because you want to know how to use that unit circle now that we've learned how to do this. So really you can get the information for this first row on the unit circle. And what I'm doing is, remember, the sine is just the y value of a point on the unit circle. And since we're going to go by pi over 2, these are the numbers that really matter. So if we started with 0, the sine of 0 would be 0. The sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. And then when you're back to 2 pi, you're back to 0. So that would be one cycle through that circle then. Then if you go to the negative angles clockwise, the sine of negative pi over 2 would be negative 1. The sine of negative pi would be 0. And then the sine of negative 3 pi over 2 would be back to 1. And then all the way around the circle clockwise would be back to 0. Okay, so that's it. So what we're going to do is, the first thing we're going to do is we're just going to get our graph put together. So it's important that you label everything. So we're going to go pi over 2, then pi, 3 pi over 2, and then 2 pi. Because see, what we're doing is we're incrementing by pi over 2. So you're counting by pi over 2. So it would be pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, and so forth. And then you reduce the fractions as they need to be reduced. So going to go to the negative ones, so we're going to get those labeled. And then from here, we have an amplitude of 3, so that's going to tell us that we need to go up to 3 on the y-axis and down to negative 3 like that. So to begin with, the first thing I'm going to do is I'm just going to plot y equals sine x. I'm going to use the color red, and I'm just going to dash that. Okay, so we have, always just remember the sine starts at 0, 0, hits its high point, goes to what we call the midpoint, to its minimum, and back like that. So that would be an example of one period for one cycle through the sine wave. And then you just keep plotting in your points as you go. Okay, kind of like this. Okay, now the next thing we're going to do is real simple. When you do the next row, if you do y equals negative 3 sine x, all that negative 3 does is it multiplies these y values by negative 3. And you can do this in your head. Negative 3 times 0 is 0. Negative 3 times 1 is negative 3. Negative 3 times 0 is 0. Negative 3 times negative 1 is 3. And then the rest, let's just do in our head. So it's 3, negative 3, 0, 3, 0, like that. Okay, it's important that you know how that 3 works. instead of just thinking that it stretches it. You need to know that all it does is it makes the y values get multiplied by -3. Therefore, it stretches and reflects at the same time. Okay, so what I'm going to do is I'm just going to pick a color, let's say like a green or something like that, and then let's just plot these points. So we have 0, 0. Then we have this one goes down to -3, this goes to 0, that goes to 3, like that. So as I go through this cycle, it'll kind of look like this, and so forth. Okay, and then this point goes there, 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 and there. So then you've got your final result like that. So you can see on there how it got stretched vertically, and also how it got reflected across the x-axis. Okay, so I'm going to label that as the graph of y equals -3 sine x. Okay, so see, it's all arithmetic and plotting points when you get right down to it. Plus you got the unit circle that'll get you started on that. Okay, going to the next page, we're going to look at one with a cosine and look at what this has. And again, the structure is that you're learning on here is you have y equals a cosine x, or let me write everything on here, bracket b x minus c plus d. So what we have here is we have an amplitude, and then you have an up transformation. So the amplitude on this is absolute value of the number in front of the cosine. That's going to multiply y values by 1/2. The period is 2 pi over b. B is always the number in front of x. In this case, there's a 1 there. So 2 pi over 1 is going to be 2 pi. Okay, phase shift, no, there has to be a number c there. So we do not have a phase shift. Okay, we do have an up. This thing right here is going to take you up 3. And then the increment of the x-axis, again, is always period divided by 4. So again, that's going to be 2 pi over 4, so that's pi over 2. Okay, so we have that. All right, so those are the key pieces of information that you're going to get from that. I'm also going to write a note to myself that we're just going up 3 like this. Okay, so we're going to do this in 2 stages. The first thing I'm going to do is, if you look at your unit circle, the cosine is the x value. So I'm going to go around and highlight the x values every 90 degrees, because that's what our increment is 90 degrees, or pi over 2 radians. Okay, then I just fill these out. So the cosine of 0 is 1. Whoops, why did I put a 0 there, Brad? Come on. There we go. We have cosine of 0 is 1. Sometimes I can't talk and write at the same time. Cosine of pi over 2 is 0. Cosine of pi is -1. Cosine 3 pi over 2 is 0. Cosine of 2 pi is 1. And if you go backwards, cosine of negative pi over 2 is 0. Cosine of negative pi is -1. Cosine of -3 pi over 2 is 0. And all the way around the circle's 1 like that. So we're going to go ahead and get our graph put together, and then we're going to go ahead and get that plotted out. Okay, so let's get this put together. So we have pi over 2, we have pi, 3 pi over 2, and 2 pi. And then negative pi over 2, negative pi, -3 pi over 2, and -2 pi. Okay, then let's see. This one we're going to go up 3, so I'm going to go ahead and take this. We also have an amplitude, so I'm going to take that up to 4, and then maybe down to -4 like that. And then I'm going to put like a little half mark on here like that, because we are going to have an amplitude of 1/2. So we need to kind of put that like that. And I'm going to label this just 1, 2, 3, -1, -2, -3, and so forth like that. So if we plot the points, starting with 0, we have 0, 1. Then the cosine just cycles through these key points. Okay, right there would be an example of 1 period of the cosine. And then I'm just going to kind of go backwards. It's real easy to get this memorized. Okay, then you can go kind of like this. Okay, and then the rest of this, what we're going to do is we're going to do the amplitude and the +3 all at the same time. What that's going to do is it's going to change the amplitude down to 1/2, so it's going to shrink it, but then the whole thing gets moved up 3 anyway. So what I do on this is I just take the y value and I multiply it by a half and add 3 to it. So that would be 3.5 or 3.5. Okay, and I'm going to do these kind of over at the side so you can kind of see what I'm doing. So I'm really just doing 1/2 times y plus 3. So if I plug in 1, see that gives 3.5. Now I go 1/2 times 0 plus 3, which is going to give me 3. Then I'm going to do -1, so 1/2 times -1 plus 3 is going to give 2.5, and so forth. You see, the rest of these we've already done. So 0 is 3, 1 is 3.5, 2.5, whoops, 0 is 3. Okay, so we've got 3 at -1, we have 2.5, at 0 we have 3, and 2.5, or at 1 we have 3.5. Okay, so see, once you get 3 of those done, then the rest of them are going to start repeating themselves anyway. Okay, so you got 5 key points. Now what I'm going to do is just pick a color. Let's go like again with a green or something like that, and just plot the points. So at -2 pi, we are up at its maximum, 3.5. At 0, we are at 3, which is like the midpoint. At -pi, we're at 2.5, which is really the low point. At pi over 2, -pi over 2, we're back to 3. And then at 0, we're back to 3.5. So right there would be one cycle. Then the rest of them just repeat. That would be 3, 2.5, 3, and then back to 3.5. So again, just kind of plotting the points. Okay, I think I missed something there somehow. Let's see. Okay, I got that. 3 pi. You know what I did? I did kind of a really dumb thing here. Pi over 2. I didn't even scale that right. Gosh. I need to start this over again. Sometimes I just don't pay attention. I get in a hurry to get things done. So let me try this again. Okay, so let's... God, that was bad. Pi over 2, pi. 3 pi over 2, and then 2 pi. All right, so let me fix this. Okay, let's go. Let's kind of go like this. 1, 2, 3, 4. And then down 1, 2, 3, -4. Okay, and then I'll just kind of approximate these. So the cosine I'm going to do pretty quickly. Cosine starts there and cycles through these key points like this. Okay, once you practice that, you'll start doing it real fast and very efficiently once you get that memorized. Okay, now let's do the cosine, the final product here, and we'll do that in green. So we have a point at 0, we're at 3.5, so I'm going to put a dot there. At pi over 2, we're to 3. At pi, we're at 2.5. 3 pi over 2, we're back to 3, and then back to our 4 like that, or 3.5. So that would be one period like that. And then from there, it's predictable. Okay, once you kind of see how it goes, you can pretty easily just put in the points. Once you got one period, you got the next one right there. Okay, so what we have then in this one is we have our two graphs. We have the cosine in red, and then we got the final product in a solid green line like that. That's it. See, it's arithmetic. Once you realize that, then graphing's not too hard to do. Okay, so let's see. This one, again, we're going to look at a sine. So let's look at, again, the structure. You have y equals a sine of bx minus c, and then plus d. Okay, so the amplitude is the number in front, and that's an absolute value. So that's 4. The period is 2 pi over b. This time b is 1/2, so you're doing 2 pi divided by 1/2. So that's 2 pi times 2, so that's 4 pi. Okay, phase shift. There isn't a phase shift yet because there's not x minus or plus something, so we don't have one there. Okay, and then the increment is always the period divided by 4. So we have a period of 4 pi. If we divide that by 4, we're going to have pi. So these are kind of the key things that we have figured out. The other thing is this thing right here is going to take you down 3 units like that. Okay, so the next thing we kind of do, what is this increment anyway? This is important. I've kind of got the increment put together for you, but you're going to start doing that yourself. So if you just started at 0 and counted by pi, you would just go 1 pi, 2 pi, 3 pi, 4 pi, and so forth. So that's how you get your increment then. Okay, now one of the things you want to learn how to do on graphing in general, and let me write down the graph we're trying to do. Ultimately, we're trying to put together this trig function. Okay, so we kind of go inside out. So one of the things I always tell students to do is start there. That's the first thing you should graph, because all that's doing is a period change. And you're going to have your key points, your 5 key points. We're just going to change the x-axis. And then the last thing you always want to do is just put these things together. Okay, and you can do that all in one step if you want to. This one I decided I'd have you do this one in 3 steps. Okay, so what I'm going to do is get my unit circle up here. And what we're going to do is this. This is really, when we go down and get our graph set up, our increment is going by pi. So we're going to go pi, 2 pi, 3 pi, 4 pi. And then we're going to do the negatives. Negative pi, negative 2 pi, negative 3 pi, and then negative 4 pi like that. Okay, now we have an amplitude of 4, which means it's going to stretch it, but then everything goes down 3. So for that reason, I'm going to go up to 4, and when I go down to the y-axis below, I need to go a little further than negative 4. I need to go, there's negative 4, I need to go and extend that graph a little bit. So what I'm going to do is this. Just go down to negative 5, negative 6, and all the way down to negative 7. Because that amplitude of 4 is going to stretch you down to a minimum of negative 4 and then down 3. Okay? Now, see, the rest of this you can get from the unit circle, but really all you got to remember when you do the first graph, which I'm going to do in red, is if you remember the sign of 0 is 0, that's good enough. You're going to have a point there. Okay, then it's going to hit its maximum of 1. Then it's going to go back to 0. Then it's going to hit its minimum. And then it's going to go back to 0. So you can memorize that. Okay, all I'm really doing is I'm just looking at these values on the unit circle, even though I'm looking at the sign of 0, sine of pi, and 2 pi. See, I'm really doing half of that. So you want to notice that if x is pi, 1/2 pi is pi over 2, and the sine of pi over 2 is 1. Okay, so basically when you change that increment, then you're changing your values. You're changing where those special points occur, and that would be 0. So what I'm going to do is I'm going to go ahead and pencil that in like this. Okay, and then that'll give us stage 1. See that? Even though you're doing the sine of pi over 2, 1/2 x, it looks just like a regular sine, but the increments are different. That's because the period changed. The problems we did previously, the period didn't change. Okay, and then from here I'll just kind of put in these values. So that would be -1, 0, 1, 0 like that. Okay, now I'll go to the next stage and I'll pick a alternative color. I'll pick like orange or something like that. So we'll do like an orange. And what we're doing is we're multiplying by 4. Everything gets, the y values get multiplied by 4. So you do this in your head. 0 times 4 is 0. 1 times 4 is 4. 0 times 4 is 0. -1 times 4 is -4, and so forth. Okay, so everything is getting multiplied by 4. Now, when we start plotting this, that's going to create a vertical stretch. So that point 0, 0 is still there. Now you're going to pi and to 4. And then that x-intercept's the same. This one stretches down to -4. and so forth like that. Okay, so that will be the second stage of the graph like that. And so forth. This one's going to go down to -4. It's going to stay there. It's going to stretch up to 4 and there. So what I'm going to end up having then is my second stage on my graph. Okay, and then finally what we're going to do on this to get the final product, I'll do that in solid. Well, what you're going to do now is everything goes down 3. So all the y values go down by 3. You're subtracting. So you're doing 0 minus 3 is -3. 4 minus 3 is 1. 0 minus 3 is -1. -4 minus 3 is -7. 0 minus 3 is -3. So you just do this in your head. 4 minus 3 is 1. 0 minus 3 is -3. This would be -7. -3 like that. Now plot your points. So really every point on this orange graph here is going down 3. So that point is going to go down to -3. This point is going to go down to 1. This point is going to go down to -3. And then the minimum is going to go down to -7. That's going to go down -3. So you'll have one cycle going through those key points. Okay, this one goes down 3 to 1. This one goes down 3 to -3. This one goes down 3 to -7. And then this one goes down 3 to -3 like that. So that's your final product like that. Okay, now one thing I always like to show students on a problem like this is it's actually very easy to check you're right. Let me show you what I'm going to do on this. What I'm going to do is I'm going to pick one of these values and I'm going to plug it into the function that we're doing and just see if we don't get -3. And this is real important to catch on to because then you can realize that graphing is 100% verifiable. So if I take the function that we're doing, y equals 1/2 x minus 3, if I just plug in 2 pi, I'm just doing that because it's easy, what would happen is the 2's would cross out, so you're really looking at 4 sine of pi minus 3. Now if you look at the unit circle, at pi, the sign is 0, so you'd have 0 minus 3, you have -3, look at that, that's what you're supposed to get. Okay, so every single point is verifiable if you just plug it in. I always just tell students, pick one and plug it in. You know, and if it's right, there's a good chance that you're right in your graph. You can only tell for sure if you check all 5 key points, or at least 3 of the 5 that have different values. Okay, now we go to something that's got a phase shift in it. So going to the next page, what we're going to begin to look at here is we're looking really at, again, this form. We're looking at y equals a cosine of b times x minus c plus d. Now see, this has to be factored out. So the first thing you want to do is you want to factor this out. Okay, so that 2 needs to come out of that parenthesis. So you have 5 cosine, bracket 2, and then fill in what goes in the parentheses. Well, that's an x, because 2 times x is 2. And then this one, just take this number divided by that number, and then that's what goes there. Okay, so you got to factor that out. And that number right there is always, what you're doing to get that number right there when you factor is you're always taking this divided by that. Always works. Okay, so now this time we have the amplitude would be 5. Okay, the period, we have the formula 2 pi over b. B is 2, so we have a and b like that. So we'd have 2 pi over 2, so the period is pi. Okay, the phase shift is here. Okay, and in this case, it's to the left. So if it's to the left, we're going to say negative pi over 2. And I don't care if you don't say negative pi over 2. I mean, really, you should. But if you said pi over 2 left, that's generally good enough. Okay, now the increment, you do the period divided by 4. So the period's pi, so we do pi over 4. So we have that. Okay, so we've now identified all the key stuff. This time we don't have a number that would cause it to go up or down. And if you do the increment now, see, if you counted by pi over 4, it goes like this. You count by the numerator. So you say 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and so forth. And then, of course, you reduce the fractions, like that's pi, and that's pi over 2, see? Okay? So here's basically what you do. Again, you're trying to take the attitude of working inside out on this then. Okay, so what we're going to do is we're going to do this first of all. So we're just going to work just on this part of the problem right here only. I mean, just that part right there. Okay, not the phase shift. We're going to do that. Okay, so what we're going to do then, and again, you can remember this. See, by changing the increment, all we've done is we've changed where those key points happen. Okay, so like for instance, if the cosine, remember, is the x value. So what we're going to do is just create these x values as we go. And if you remember, the cosine starts high, then it goes to x-axis, then it goes low, and it goes back to, whoops, put the wrong thing there. So it goes low, back to 0, and this right here should be a 2 pi. Nope, that's a pi, so that would end up being like this. So it's 1, 0, negative 1, 0, then back to 1. Now keep in mind, what you got to understand on this is, I want to show you what happens here. See, what we really did was we're doing the cosine of 2x. So if you plug in pi over 2, then what you end up getting is you get the cosine of pi. And the cosine of pi is negative 1. That's why that value changes the way it does. Okay, and then these things just go backwards. You would have 0, negative 1, 0, 1 like that. Okay, so really when you get this put together, you're going to just start inside out, and then you're going to just do the same points you do on a cosine, but the x values are different. So when we scale this, we'll go pi over 4, pi over 2, 3 pi over 4, and then pi. And we'll go through those key points like this. So this is negative pi over 4, negative pi over 2, negative 3 pi over 4, and then negative pi. Okay, and then we have an amplitude of 5, so it makes a lot of sense on this problem to go all the way up to 5, and then all the way down to negative 5 like that. Okay, all right, so what we're going to do is we're just going to plot this. And see, the thing, if you can remember this, cosine starts high at 1, y value of 1, x-intercept, low value, then see you can very, very quickly plot those things in like that. Okay, so we just kind of put those in. And then that will take care of the first line like that. Okay, all right, so now we're going to move on, and we're going to, I'll pick like another color. I'll pick something like, I don't know, let's see, maybe blue or something. Let's do like a blue. And what this is going to do is this is going to change the amplitude. So that 5, it's multiplying the y values by 5. So 1 times 5 is 5. 0 times 5 is 0. Negative 1 times 5 is negative 5. And so forth. So you can put those in. Just in your head, you just realize you're multiplying by 5. Okay, so what that's going to do is move this point up to 5. This point stays the same. This point goes down to negative 5. This stays the same. And that goes to 5. Okay, so what you have now is you have that. Okay, and then just keep cycling through the points. Okay, and then now you've got your cosine wave like this then. Okay, that takes care of that. And then the last thing we're going to do is you have a phase shift. So if you look at your phase shift, we were basically doing this. We were phase shifting pi over 2 to the left. So what I'm going to do to get this final product, let's do that in green again. You can start anywhere you want to. So like if you started here, that one moves over that one moves over. Now you're moving pi over 2. So the distance from pi over 2 to pi is pi over 2. So this one right here is going to move to that point there. Okay? This point right here is going to move there. This point here is going to move there. And see, once you do a few points, then the rest of it's easy to do. So you've got low, midpoint, high, midpoint, low, midpoint, high, midpoint, low. Okay, so once you get just a few of those points phase shifted, then it's not too hard to figure out. So that is your final product like there. Okay? All right, let's do a check on this too. So I'm going to go way back to the beginning, even the factored form. Or actually, let's go the factored form. There's a benefit to doing that. So we have y equals 5 cosine of 2 times x plus pi over 2. And what I'm going to do for simplicity is I'm going to just plug in negative pi over 2. Okay? And that's just because it's easy. So you would have 5 cosine of 2 times negative pi over 2 plus pi over 2. Well, that's really going to be negative 5 cosine of 0. Cosine of 0 is 1, so 5 times 1 is 5. Well, look at your chart. Okay, when x was negative pi over 2, okay, what you were going to do at negative pi over 2, notice you had pi. Okay, now what I'm going to do to fill in this row here is I'm just going to take the values from my final graph. When x was negative pi, the final graph was negative 5. Then it went to 0, then it went to 5, and then from there you just start cycling. Okay, so at 0 we're at negative 5, pi over 4 we're at 0, and then, let's see, 5, 0, negative 5. Okay, so it's kind of like a phase shift. See, if you look at this, what I want you to see is this point, when you phase shift, it becomes there. That point, when you phase shift, it is there. That point goes there, and so forth. So it's kind of like that goes there, and so forth. Everything gets moved. All those y values on that previous graph get phase shifted. Okay, so that's how that would go. Okay, one last problem then I'm going to do. Let's see, I think I had some kind of mistake on this thing too. So I think number 5 is it, and I think I didn't notice this, but I think we already did this problem, didn't we? Yeah, okay. I think this stuff beyond number 5 is a bunch of trash. So we've already done that. I hope you guys noticed that. This one, I can't remember if we did that or not. I think that was definitely not intended. Yeah, I think that last problem wasn't even intended, so I'll go ahead and go through this point. Although there's no graph on there or anything, I'll go ahead and I'm just going to block that off because that was actually not intended. I don't know how that got on there. So let's finish then with this problem. This problem right here has it all. So everything is going on in the problem. So first of all, to start with, your amplitude, again, be careful. Always realize that your amplitude is a positive number. Okay, your period is 2 pi over b. So b is that number for pi. So you're going to go 2 pi over 4 pi. The pi's are going to cross out, and that's going to reduce to a half, which is okay. You don't have to have pi's on the x-axis. Okay, this is in a factored form. So that means that is your phase shift. So that would be pi over 1/8 to the left. Okay, and then this is a vertical translation. So that's up 3. Okay, the phase shift is to the left because that's a plus sign. Okay, the increment of the x-axis, again, you always take the period, divide by 4. So the period is 1/2. If you divide by 4, you're multiplying by 1/4. So that means the increment is 1/8. Okay, so we've kind of got all of the basic pieces of this put together. And then the increment, see if you count this out, you would just go 1/8, 2/8, 3/8, 4/8, and then 5/8. Okay, and then you would make it through your points like that. So you're just going 1, 2, 3, 4, and keeping that denominator alone. Okay, So what we're going to do on this one now, we're not making a table of values. What we're going to do is just count out this increment. So we're going to go 1/8 and then 2/8. See, 2/8 is really 1/4. Then we're going to go to 3/8. And see, 4/8 is really 1/2. So I do want it labeled that way. And then 5/8. And you can go out further if you want to. Okay. So this says graph through one period starting at the phase shift. The phase shift starts at -1/8. Okay, so what we're going to do is we're going to put this kind of together like this. And again, I'm doing this in stages. See, I'm working inside out. So I do that, then I do the amplitude, then I put that in order like that. Okay, so let's see. The y-axis, you have an amplitude of 1/2. You have a reflection. You're going up 3, so it makes a lot of sense on this one to go up to 4 actually, because you're going to end up going from 3 and 0.5. You're going to have a max of 3.5. And then do this the same way. -1, -2, -3, -4 like that. Okay, so we're going to start at the phase shift. So we're going to do this graph first. So here's the way that you want to process this. Okay, you know a sine starts at 0, 0. But that's going to phase shift to the left pi/8. So that point is not there. That point is there. So we're, instead of starting at 0, 0 for that basic sine point, start there. Then start cycling through your key points on the sine wave. Okay, and all you got to do is go through a period. So this part right here is not really going to be necessary. Okay, so this is going to be my first graph, like that. And that's the basic sine wave that starts here gets moved over. Okay, now we're going to tie in this piece. So I'm going to do this like in, say, blue. And this multiplies the y values by -1/2. So you want to do this in your head. So you're doing really 0 times -1/2 is still 0. This is 1. 1 times -1/2 is -1/2. So that moves there. Then you're doing again 0 times -1/2 is still 0. And then finally you're doing -1/2 times -1. So that moves up to 1/2. Okay, so see your key points are going like that. Now it's going to go to 0, -1/2, back to 0, because once you get one period, then you're okay. Okay, and then the last thing I'm going to do is the final product. I'll do in green again, and a solid line. Okay, everything goes up 3. So take all these points on the blue graph, which are these places here, and take those up 3. So this is 0 plus 3 is 3. This is -1 plus 3, -1/2 plus 3 is going to be 2.5. So that goes there. This is 0 plus 3, so that's 3. This is 1/2 plus 3, so that point goes to 3.5. And then this one is 0 plus 3, it goes there. So basically, I'm a little off on that point right there. So that would end up going like this. So you have 3, 2.5, 3, 3.5, and back to 3 like that. So that would be one period like that. What I'm looking for is the final y values. Like that's 3, 0, 3, 3.5, and 3 like that. So that's your final product. Okay? All right, and again, what I'm going to do is I'm going to check one point. Okay, so you're doing the graph -1/2 sine of 4 pi x plus 1/8 plus 3. So if you want to check one point, what I would do is I would use -1/8 because it's so easy. All that's going to do is make this 0. You can do this in your head. So you're going to get -1/2 sine of 0 plus 3. Okay, that whole thing is going to go to 0. So that's -1/2. The sine of 0 is 0. Therefore, that's equal to 3. And if you look at that point, see, that's what we got. When x is -1/8, we got 3. It takes very little of your time to do that. Okay, so that's the 5 problems that I wanted to go over on that then, and that'll wrap us up.